Welcome to the Smart Charge by Ridergy podcast. This is Claudio Geiken, founder and CEO of Ridergy. This is your show to learn about all things energy management and smart charging innovation for electric vehicles and fleets. Welcome back to Smart Charge. Today we're getting practical about heavy-duty electrification with Michael Clarke, who co-created the eTrucker from electric-trucker, a driver-built app that helps eTrucker drivers find truck-suitable charging across Europe with filters for pull-through bays, overnight parking, and realistic truck-specific routing. Before that, he worked at companies that are super interesting like Tesla, Porsche and NIO, where we also dive deep into and learn of the differences in the interesting projects he worked on. For example, the Smart Charging NIO app. The team behind eTrucker didn't build this from a desk. Co-founder Tobias Wagner logged 100,000 electric truck kilometers in a single year to shape the tool. At launch, the database covered 575 truck-ready charging parks, and community contributions quickly added 100 more, a driver-verified dataset the team describes as Europe's largest for truck-capable sites. eTrucker went live in 2024 with a 3-person team, and the app is now available on Android with a few thousand installs and iOS. Today, Michael and I dig into how driver feedback improves data quality, what truck-suitable really means on the ground, and what's next for bookings and live data and eTruck innovation. Buckle up, let's roll. All right, Michael, nice that you're here today. How are you?
Thank you, I'm wonderful today.
You came from Munich all the way to Berlin to have some business meetings, right?
Yeah.
And of course to record this.
Yeah, looking forward to it.
So before we start and talk about all the things around the electric-trucker app, which is your current focus, let's understand a bit who is the person, Michael. What's your background?
Thank you. Yeah, so I grew up mainly in Germany, before that a little bit in America, but went to university in Munich, studied political science, then finished that and then decided I want to understand more of the world, so I started physics and then studied a bachelor in physics. That was a lot of fun. Very stressful time, and enjoyed that. And then I had a great opportunity to do an internship with Tesla in Munich at the supercharger team, and had a wonderful year there. Learned so much back in 2016 about e-mobility, and Tesla was on a roll back then. And really grateful for that experience. And then I got an opportunity at Porsche in Stuttgart to launch their global destination charging program. So AC chargers mainly at hotels and other luxury locations. Running that for 3 years was also an awesome opportunity. And then I got into the vehicle product management at Porsche for all the electric vehicles and hybrids, and also future vehicles, specifying, the charging performance, where the charge port is, the route planning, all that fun stuff. Really thankful for that. And after that, I wanted to come back to Munich and found an opportunity with NIO, where I also did product management, but more on the ecosystem side. So wall box, chargers, high-powered charger. We'll maybe get into those stuff later.
Right.
And that was a great 3 years of my life, and now I'm off to new adventures and with the eTrucker app. So
interesting.
Yep.
And so how much would you say are you American, and to what extent are you German? So you have a certain definition for yourself?
I feel German, even though I'm not German. I'm Austrian and American and Irish. So, I feel German. My dad's from New York, and I enjoy it there as well.
Right. And the times at Tesla, when you were there in 2016, Can you elaborate how it was at that back then? What type of when you said it was really before the Model 3, I understand, and
Yeah.
what were the challenges at those days that, if you remember?
So getting the word out. So one of my jobs was building the destination charging network there as well, and just
Like at Porsche then afterwards.
yeah, so very similar. But yeah, cold calling hotels, explaining to the front desk, what Tesla is, were electric cars, and usually they were somewhere in the Alps and haven't heard about electric cars or Tesla at all, and sort of explaining the story, convincing people of electric mobility and that it's the future. It kind of also convinced myself, I got good at pitching that, and we really grew the destination charging network. But I also helped out with the supercharger network a little bit, and just the amount of professional and optimization and really cutting costs. That was really impressive, and I think it's awesome what the Tesla supercharger team has done over the last few years. Really an unmatched network, and great to have a front row seat to that.
Did you meet Elon Musk or Philipp Schröder at those days? I'm not sure.
No, we some of the European leadership, but of course this ethos was there, and Elon was sort of in the back of everybody's mind, and the spirit there was really infectious, and was just great part being of the team. I'm still friends with many of them, and it's a great community.
And what's the latest on the supercharger network? There was this period, I think it was last year, where it was Elon, I think, wanted to shut it down somehow. Do you know what's the status there, or what happened exactly afterwards?
So the way I understood it is that I guess Elon wanted to make an example of somebody, and it unfortunately was the supercharger team. In the end, I think actually it was a bigger story than maybe what actually happened, especially in Europe. I guess there was downsizing, but not to the extent that you heard about in America. Mm. So but it's an interesting question. The role of an OEM in the charging industry. That's, I think, one of the core questions that every car maker is battling with, and many have sort of followed the same game plan. Many have come to similar conclusions and are now maybe changing their approach. That's always an interesting...
What are you thinking about when you say changing their approach?
So, there was Ionity and that sort of coming together, building out infrastructure, getting the basics right. Then there is always the question of, okay, do you have your own MSP or mobility service provider, the charge card? Essentially, what's the role of that, or do you share those resources? And then now we see in the premium segment, more of these premium charging lounges popping up more and more from, I guess, Porsche and Daimler. So I don't think everybody's sure exactly, what the long-term role will be, but definitely a lot has happened, and it was a great time to experience and learn.
And then talking Porsche, at those days you said you worked on route optimization, destination charging, and what was like?
Yeah, so I was a product manager for charging. That means, on the vehicle, the Taycan was a very special car, of course. First car with 800 volts, first car with plug and charge, first car really with in the beginning, not so much, but later on, then a very good turbo charging planner is what we called it. And getting that right, sort of understanding what the user's needs are, what they want to see, what is a good route. The definition of that is sort of, very difficult to grasp or to define in software. And some of those learnings now also translate over to what I'm currently doing, so I really enjoyed that. But also back then we had to imagine what the future is like, what charging speeds would be coming. The Taycan launch was 270 kilowatt peak power, and we couldn't imagine, 300 or 400 kilowatts. And now some of the Chinese cars are just coming with 500 or more kilowatts. So imagining the future was really challenging and fun. And but also looking into payments, what role does plug and charge play? Those kind of questions, were a lot of fun. And lastly, the whole topic of fast charging performance. So not just hitting that peak speed, but sort of preconditioning the battery, making sure all the things are optimized, that you can really charge quickly. Because everybody says, okay, it depends on so many factors. That's partly true. In the end, it's only battery temperature and SOC that's really going to determine how fast it charges at the appropriate charger.
Right. Yeah, we'll come back to that. And then finally, before today, so to say NIO, you said ecosystem. So can you elaborate? So was especially working around charging aspects, I understand. Yeah, what type of challenges or topics were you mostly looking at?
Sure. So on the one hand, just starting from a very simple AC home charger, getting that, and NIO makes all their own chargers. In China, in Wuhan, actually, there's a factory that makes the chargers, and getting those certified and ready for the European market, having the appropriate app and the functions there. And I also decided early on, actually, to take the whole topic of smart charging sort of out of the wall box and more into the car itself. And then we developed a sort of NIO smart charging, a vehicle function. And but NIO is also one of the biggest charge point operators in the world. But in Europe, we also had about 100 DC fast chargers up in the Nordics. And operating those and getting the hardware right, integrating a credit card terminal, that was a lot of fun. And also on the battery swapping station, we're also charging batteries there, and also the topic of calibration law, for example, is relevant. And
Interesting. So you had to have a look at all these aspects that you're just referring to.
Sure, and especially having sort of the role of NIO has a battery swap technology, meaning that the cars can swap their batteries out quickly, and sort of how does that change what the needs of the vehicle are? That was quite fun.
And when you say that you prefer to look at the vehicle for smart charging instead of this charger, AC charger, what was your reasoning or the rationale behind it?
So the rationale behind NIO smart charging is that I saw a way for the vehicle to really use dynamic electricity prices to optimize the charging session. And with essentially 2 clicks, you just activate smart charging in the vehicle. You set a departure time or charge by time, and the vehicle automatically knows the day ahead prices, picks the cheapest hours of the day to charge, and that's when charging happens. We just send commands directly to the vehicle. No setup, no login, no tokens that need to be handled for the user. They just need to make sure that their electricity tariff is dynamic, that they have a smart meter, but essentially it doesn't matter which energy provider they have, because the dynamic electricity prices mainly follow all the same day-ahead signals. So
makes sense. But when you say specifically that you prefer to do via the vehicle instead of the charger that this NIO is building, what did you mean with that?
So essentially, if we do it via the vehicle, it doesn't really matter what the charger can do. It can be a dumb charger or a non-connected charger from any manufacturer. And doing it through the wall box has the challenge that the communication with AC charging is actually quite limited. So for example, the charger doesn't know what the state of charge of the vehicle is, and therefore doesn't really know how much energy the car wants or needs, which kind of limits what you can do. Now with ISO 15118 and the mandate for that in the future, also for AC home charging, That will partly change, but we said, okay, we can quickly here implement a function that has real value to our users, especially in the Nordics that already have dynamic electricity tariffs and smart meters. And we just went ahead and did it. Didn't cost much to develop or make. The data is, the day-ahead prices are freely available. So it was really simple to do and solved sort of one of the core problems that many car makers are battling with.
Yeah, no, totally right. Interesting. And let's geek out a little bit. I think many people either don't know, or if they know, they probably don't know why. So indeed the state of charge, which is how much battery you basically still have and how many kilometers you can still drive, is not something that is communicated to the wall box in an AC at the AC level, but in the DC it is. So why is that? Do you know the technical background behind it? And when is ISO 15118 going to be implemented in all the AC chargers? So if somebody doesn't have a NIO, but wants to see a state of charge through his wall box that is listening, when can they expect to see it?
Yeah, so AC charging today works quite simply using pulse width modulation, or PWM signal, and there's essentially only sort of the state and the charging current that can be communicated from the wall box to the vehicle. So the vehicle, the charger, for example, says, okay, you can charge with 10 amps, for example. And actually, the number of phases that you charge on isn't also defined. The vehicle will just take how many phases, 1 or 3, as they get. So actually, even the charging power doesn't explicitly get communicated during AC charging, because the only point of doing this is to protect the wires, either the wire from the charger to the vehicle, or in the house, the cable from the distribution box to the charger. And that's what you're trying to protect. So you set a maximum charging current, and then that is communicated to the vehicle. But the vehicle is actually the one in charge pulling the energy through the onboard charger. So the charger can't actually directly change how much power goes through it. It's just sort of monitoring what's going on. And in case the vehicle is pulling too much power, it can shut down the charging session. But there is not much more going on. And wall boxes are essentially just an adapter to the vehicle with some safety functions built in. So that's how it currently works. The EU, with the delegated act that was recently announced, said that from 2027 onwards, AC wall boxes at home need to support ISO 15118-20, which means that you now have sort of a high-level communication going on. So you can send data packets back and forth. You need sort of an additional small modem in the charger that makes it also a little bit more expensive. And of course, then you need to implement this software stack. And at NIO, we experienced, for us, it was really easy to implement this AC charging protocol. We did it ourselves. Now, with 15118, it's not something that an AC charger manufacturer can realistically do in-house. You need to rely on some of the software providers in the ecosystem to give that to you, or you need to buy it actually from them. So both on the hardware side and on the software side, it does make AC charging actually quite a bit more expensive. So I'm not a huge fan of this 15118 mandate for basic AC charging, especially considering that if you actually control the vehicle, you can do really cool smart charging features there as well. I guess the hope there is that, essentially all home chargers become bidirectional in the future, and all vehicles would be bidirectional, and it solves all our energy problems. But that is an assumption and not a fact, and it's quite interesting that they decided to mandate that.
So on the last point that you made, you say that you need to have the AC charger to be that smart by implementing ISO 15118 just to make the bidirectional case, right? You can do it only via the vehicle.
So bidirectional charging, of course, you need a way for the vehicle and charger to communicate with each other. So the charger, for example, needs to say, hey, now I want you to discharge this amount of power. And that's a message that in the old communication protocol just didn't exist. And so you need this high-level communication. And that's actually sort of the main issue about bidirectional charging. Nothing actually changes in the wall box. It's just, a wire that's going through it. So yeah, the magic happens in all the communication. You also want safety because, if the power goes out and you have people working on the power grid, you don't want vehicles to suddenly start discharging power into a grid where people are touching the wires. So a lot of safety standards and grid codes go into that.
Yeah. So just to be clear, if I have an AC charger right now at home with a vehicle that is bidirectional, that could be discharging, there's the vehicle to load. I think there are plenty of vehicles out there that with AC can discharge, but only to an appliance. If you want to discharge to your home or if you want to discharge to the grid, the big hurdle is having this protection on the charger at the charger level that protects, so to say, the grid from flows that shouldn't be flowing if there is a blackout, as you say, and some people are working on the grid, right? That's one big thing. But then the software stack for bidirectional charging could be actually only in the vehicle, or am I wrong in that you could run the V2G or the V2 Home algos and software only in the vehicle? You don't really need to upgrade the wall box, would you?
I guess the way ISO 15118 is currently set up is that the idea is that the charger is sort of centric to this smart charging approach, and that the charger from whatever source, maybe a home energy manager or maybe from a grid operator, gets a signal to please discharge energy into the grid. And when you do that, of course, the vehicle needs to exactly match the frequency of the grid.
Right.
And so concerning the grid codes, you need to have defined behavior. What happens if that grid frequency, which 50 hertz in Europe, what happens if that deviates by 0.3 hertz for how many seconds? What are you supposed to do? Are you supposed to lower the power? Are you supposed to completely shut off? Because that can sort of trigger, if multiple devices in the grid behave incorrectly, it can make blackouts worse.
And these grid codes, are they only at the TSO level, at the transmission grid level, or also at the distribution grid level?
Mainly the TSO is in charge of maintaining the grid frequency across his grid. So mainly they are responsible for buying and implementing grid services. So in that case, yes, they would be in charge there. But also, I guess they delegate some of the responsibilities to the distribution system operator. And the distribution system operator sort of has additional requirements, of course, because they don't worry about the frequency, but they worry about sort of transformers being overloaded and similar things.
And touching back on the smart charging that you did you also consider self-consumption of solar energy, or was it purely focused on the day-ahead spot market optimization?
So yes, the day-ahead optimization is the first step. Of course, you can also do solar optimized charging, and you can do solar optimized charging essentially in two ways. You can have your house measure your PV production and the house grid consumption and how much power you're exporting into the grid, and you can sort of increase or start charging to consume that. But I also looked into alternative, because this, of course, requires a lot of integrations and a lot of knowledge sharing. And I looked at, also part of my master's thesis, in can you actually get similarly good results by just looking at professional solar intensity forecasts. So big providers, operators of solar panels, they buy very accurate solar forecasts, including sort of wind and cloud movements, because their job is, on the other hand, to bid on the day-ahead market and say, hey, I'm going to provide this many or this much power at a certain time in the future. So they need very good forecasts, and we can use those at home to also make a pretty good estimation of how much power the solar system will be consuming, and you can make certain assumptions about what your own house grid consumption will be, and then you get like the 80 or 90% solution, which is much better than nothing, and actually for most people probably good enough. And the question is sort of how much additional cost and work do you want to put into those last 10% of optimization.
So is that was that implemented? So as a NIO driver, can they activate that feature today?
The plans are ready for doing a solar optimized charging, but I didn't get around to implement it.
Okay, well, very nice indeed that you did the dynamic already spot feature, because that's something also quite unique. No, I'm not familiar with many OEMs all the OEMs out there, but it sounds like quite unique as well as a project. No,
I think what enabled us to do it is we took ourselves out of the equation. We didn't try to get value out of this. We didn't try to earn money through this function, and sort of that clouds your vision if your primary focus is to try to earn money with each function. We just flipped it around and said, okay, what can we do for the user to fix his problem? And we found a solution that's really cheap to implement, works really reliable, and just does it. But of course, NIO doesn't earn any money with it, but it solves a problem.
And is it being used a lot by NIO?
Yeah, we're super happy that in the Nordics, it's everybody has it. Of course, the price variations aren't as big as we experience here in Germany, but still they save a lot of money using it, and it's, as I said, super easy to set up. Anybody can do it, and it memorizes the location where you are, and every AC charging session inside of this bubble will then be smart charging optimized, and everything outside, of course, will not. So yeah, nice. It's really easy to manage.
Did you also quantify how much they saved?
We calculated sort of what the earning potential was, and we figured out that you can probably save around 30% of your electricity costs. But as I said, it's in the Nordics, the variation in pricing, because they have relatively consistent power generation,
hydropower
isn't that big as the potential is in Germany.
Right.
But here we don't have the smart meters, so
yeah, that's the problem. Yeah, you need the goddamn smart meters in Germany. But let's not touch upon that topic. There's plenty of others more interesting things to touch upon. And just the battery swapping, I find that as well fascinating. I think NIO is probably the #1 company out there doing this. And can you share a bit more about the usage? Like, interestingly, you said there's the AC wall boxes. There's also the HPC cables that NIO fixed DC.
Yeah, we have a 500 kilowatt DC fast charger,
wow.
Which really, is one of the fastest chargers in Europe, and yeah, they work great.
And so, are the users using these swappable batteries more than the fixed HPC, for example? And what do you also make of NIO being the only one really pushing that concept further, and not other OEMs, for example?
Yeah. So NIO usually has battery swapping and high-powered charging at the same location, and the user usually has the choice which one to use.
Interesting.
And indeed, if both are available, they usually choose to swap, just because it's that much faster. It's fun, and it works very well. So battery swapping really is a great technology. It's a niche. I don't expect every manufacturer or everybody to need it. There's a certain user group, for example, taxis. They really love it. For them, it's just solves a lot of issues, and for them, it's the right thing to do. I don't think every car in Europe needs to have it. But I also have been to China a few times, and there, of course, battery swapping is just a way of life. I know people there that haven't charged their car at all. They just swap. And there's so many swap stations there. And if you really have a good network, it just works.
And what do you make of other OEMs not following suit?
I completely understand. It does limit yourself a little bit in sort of what kind of cars you can make, sort of the sizes of the vehicle, and it does add a little bit of cost, but it doesn't prevent you from fast charging. So NIO vehicles can charge with 240 kilowatts, even on a 400 volt system. So that definitely, you don't have to make compromises on the fast charging side as well. But, for me, what made battery swapping so interesting is that actually after battery swap, you have an empty battery. And the question is, what do you do with that empty battery? Do you charge it immediately, or you essentially use the same algorithm that we use for the cars? You do smart charging. So you wait for the electricity price to go down, and then you charge your vehicle. So you can kind of offer a fast charging experience, but at sort of AC electricity prices. And that's, I think, really neat that you can just, use the energy when it's good for the grid, when it's good for, when it's cheap.
So what's the price actually if I go as a NIO driver and want to swap my battery here in Germany, for example?
Yeah, it depends also a bit on location and country, but I think we're under 45 cents in some areas.
Oh, it's quite a competitive price,
yeah.
Nice. And you have worked at an American company, a market leader in EVs in the Western world, and so far. And then you worked at Porsche, that is definitely known for high performance and has built this Taycan with being an awesome EV, and then NIO that we just discussed as well, standing for also an innovative Chinese player that they're more around, given Xiaomi, given BYD, and so on. But so, what's your take on the future of the OEM leadership board, so to say, and especially the EV world?
Yeah. So, they have been very different experiences. The Tesla was sort of special. I think it was lightning in a bottle. I don't think it's easily recreated. I also don't think other American OEMs are similar. I guess the European model, there are certain similarities between the German OEMs and the way they think, the way it works internally. You have a lot of assurance. Sort of what the baseline is. What the decisions are. You can count on that to a certain extent. With a Chinese car company, the decisions are quicker and more. They can change from day to day, and that enables an awesome innovation pace. Something that is also expensive to keep that innovation pace, but it's just each iteration makes the product better or cheaper, and that's really, really hard to compete with. I don't expect all the Chinese OEMs to be the same. I think there's probably big differences between sort of startups and newcomers and sort of the more established players. But in general, having a country focused on e-mobility really unlocks a lot of potential, and the cars are really good. Yeah.
So let's now switch gears and talk about the next phase where you're currently in. What drove you as well to change now from NIO, and I think what is it 2 months and start electric-trucker app or company, or it's officially, what's the name of the company?
It's electric-trucker Media GmbH, but the app is called eTrucker. And what sort of fascinated me is that charging at some point is gonna become normal. It's something actually I realized at Porsche is that we had a charging product manager, but we didn't have a refueling product manager. Gas stations are kind of there's no need to have sort of expertise there. And I don't know if charging will go down that road. It definitely seems complicated enough that there'll still be interesting things to do. And I don't think on the car side we've solved all the issues yet. But I saw an opportunity to go into the heavy-duty trucking area. Also, a little bit with the intention of maybe not recreating similar mistakes we did with passenger vehicles, sort of using those lessons learned to really get it right the first time. And that's why I teamed up with Tobias Wagner, who's the electro-trucker, and I was fortunate enough to create the eTrucker app with him. And Matthias Brands, who's our software engineer, and together we decided what we wanted to do. We mainly made this in the first step to help Tobias in his day-to-day work. He's still a truck driver. 2 weeks ago he went from Turkey to Portugal in essentially one go. And there, the eTrucker app really helps his day-to-day work. So the app tells you when you will arrive at a certain station. Is it inside or outside your remaining driving time? You can filter for specific CPOs, and he can also see sort of which locations are actually suitable for overnight charging, because many of the infrastructure and high-power chargers that are built for trucks are actually built for that sort of 45-minute break period during the day, where you're sort of expected to leave after you charge. But actually, truckers also have to do a 9 or 11-hour break later in the evening. And that's, I think, for me, the more interesting charging sessions, because that's actually where you charge more energy than during the short break.
Right. So one step back, what was the background story on how it all started? Like, did you meet Tobias at an event or?
Yeah, we met at I think an Aeon Drive Summit a little bit over a year ago, and we hit it off. I guess I asked some of the right questions. I was interested in understanding how it works. I had some experience with navigation systems and apps and the mobility service provider side of things. And yeah, we said, okay, let's do this as a side project, see where it goes, and started to rate and evaluate high-power charging sites on their suitability for trucks, and brought that together. Came up with an app, and just launched it.
Okay. Yeah, and the company that's built, you are the 3 founders that you just mentioned.
Yeah.
And so I understand, Toby is still like in his trucker mode, and obviously helps out with very practical experience. And the other 2, what was it? Matthias was the other co-founder. You are like now full in and trying to bootstrap a bit and living off your savings to make it work.
Right. We don't have many expenses right now. Of course, we do want to provide a premium experience. That's why we use sort of very good maps. We use Google Maps, for example, because they have very high quality satellite imagery, which we find important for the truck driver to sort of visually confirm that, yes, there is enough space there that I can charge or park there after my charging session.
Compared to other map providers like OpenStreetMap, right?
And if you don't have that satellite view, you're missing out on a lot of context that helps increase the confidence that you'll have a successful charging session there. Makes sense. We also then, use TomTom for very good truck-specific routes. So we can tell you exactly when you'll arrive there with a truck, and you're only allowed to drive, 80 or 90 kilometers per hour in certain countries. And we take that into consideration, and also the route you have to take to make the best recommendation and visualization possible. So that costs a little bit, but it's worth it to us.
Right. And just to understand really the problem in in detail and well. If I'm a trucker right now and I want to drive an electric truck, what's the key problem that I'm facing that you're trying to address here? Or the top three, if you want to elaborate on.
So trucking has gone down the road where actually now we have quite good electric trucks already, even though from some of these companies, it's the first or second iteration of their heavy-duty truck. They're actually quite capable, and we see often that they're used on relatively boring routes, point to point, every day the same route. That's also difficult, and you also need charging solutions for that. You need to either build depot chargers at the origin or destination, or you find a charging site in between where you go every day. But it's very repeatable, very predictable. There, our app would maybe help you determine if the charger you usually use is occupied or not. But what I think is more interesting, and what Tobias is sort of trailblazing into, is this whole long-haul trucking area, which many people didn't think is ready for electric trucks yet. But we actually believe that that's where they can best show their advantages, have lower operating costs, and to get the payback period on a slightly more expensive electric truck, you need to drive a lot of kilometers, and the trucks that drive the most kilometers are long-haul trucks. So we want to sort of open up that space, make it possible, give truckers the right tools to succeed, and we believe the eTrucker app is sort of the tool they need to never have worries and always find the right charger for their situation.
So just to be again very specific, and sorry if I'm trying to really nail this, but like if I'm a trucker and you're trying to pitch me your solution, so to say, what's my problem why I would need you, so to say, and if I have my let's say my truck from MAN or any other OEM, why would I need you?
So we found actually that even for diesel trucks, many truckers don't really use the onboard navigation system of the truck. They have sort of either tablets or phones with sort of other navigation solutions, often also coming from the logistics company themselves, or tablets built into the vehicle. So yeah, the onboard navigation system of most of these trucks don't have very good POI data on where the truck can charge. And that's the main pain point we're solving, is by giving him or her very clear instructions on where they can go to charge. And it's really easy to operate. There's just one layer and really big buttons and very good overview of where you are.
So where you answer my question, so to say, okay, if I need to deliver something from A to B, you answer my question, where should I charge?
And that's sort of also one of the things we noticed, is that there are big differences in how autonomous or how much responsibility the driver has. We see some logistics companies that define everything for the trucker, exactly where they need to be, where they're going to charge, what route they're going to take. And maybe they optimize that, and they have a good reason to recommend that. On the other hand, we see some logistics companies that sort of give roughly the time you need to be here at this time, but how you get there is kind of up to you. And what we see, and what it's great to have Tobias on board, is to show sort of how unpredictable the day is. If you run into a traffic jam, or you need to reroute, all the best plans, they just break down. And having a good and robust eTrucker app to help you out in these situations, we believe brings a lot of value to this, and just unlocks long-haul trucking for most logistics companies.
And so one of the big issues you said, so when you want to help me understand where to charge, is to understand which sites are truck friendly, so to say, right?
Yep.
So that's the kind of answer you're giving me. What are the best sites for me? Which ones are truck friendly, right?
Yeah, so we define truck friendly to have at least enough space on site to park your trailer, decouple, and then go to the charging station to charge. That's sort of the bare minimum. If you don't have a place to park your trailer in sight, we don't usually consider that. And also, of course, on the way to the charger, you can't go through a road or something where it's prohibited for trucks. And often there is either a weight limit or a height limit that prevents you from using specific chargers. So we take all of that into consideration. We are also actually very conservative about what we include. So we don't want to include any sites where there's potential for pedestrians or children or just a lot of traffic. We don't believe those sites to be truck friendly and don't want to route any trucks there. But we found that actually, quite a number of sites is truck friendly. We also, of course, include all the sites where you don't have to decouple, sort of the pull-through locations. And even if you sort of activate the only pull-through location filter, you can still pretty much get from A to B across Europe. Of course, the challenge for optimizing this is you want to find a charger that is as close as possible to the end of your driving time shift. So when you start driving, you can drive for 4.5 hours. You kind of want to find a charger that's between 4 hours and 10 minutes and 4 hours and 30 minutes. Nothing over, but also nothing considerably less, because then you're sort of losing time. So really having those options helps truck drivers achieve the same performance as diesel trucks.
So the key dimensions are, on the one hand, understanding which sites are truck friendly, and the second is which sites are truck friendly along my route and are able to fit within this driving constraints that are these 4.5 hours that you need to then take a break with. Yep. And then daily limits and weekly limits, right?
Yep. So that's the most important thing. We also have the long pause filter, where you can then say, okay, this is a location where I can actually stay the night, can stay 9 or 11 hours, and charge up there and not worry about things. So these are the things we believe are most important. This is sort of the data model we built around. It actually doesn't perfectly fit into this OCPI data model where you sort of describe charging locations, which is sort of the agreed upon standard to communicate charging locations that MSPs use to communicate with charge point operators. So, yeah.
All right. I think that makes sense, yeah. And the solution you provide, we touched upon already a bit. So it's a navigation tool, a map, so TomTom and Google Maps. And then we have also this for these charge point data. Then I think I read in articles eco movement, right? Mm-hmm. So you get that, and then you combine it all together, and then as a driver I can easily say I need to go from A to B, and you tell me where I need to then charge best, and I can also set some more filters myself, right?
Yeah, so currently we're not really telling you, okay, this specific charger is the one you have to go to. Okay. We're more about showing you all the options along your route, so you can make the best decision. Truck drivers for us are professionals. Mm-hmm. They're experts at what they do, and we believe that giving them just the right tools to succeed is the best way going forward. And for us, it's great that we can also rely on a community. So we really take this POI data topic very seriously. We have a great partner in Eco Movement who just gives us a great base layer of where the chargers are. They give us live occupancy data, and on top of that, we put our attributes. And actually sort of the eTrucker community is helping build that. So on each charger, if you open it up, you can sort of report an error, but you can also sort of upgrade a charger because we know where every DC charger is. You just click on it and say, hey, actually, I think this is a DC charger for trucks. and then we take a look at it. And if Tobias and I agree that it's truck compatible, we add it to the main map. And we also point out a lot of locations where we believe truck charging might be possible, and then we have a community feedback mode that you can go into and say, hey, actually, I've been to this charger. Actually, no, it's not truck compatible. Let me let them know that. And then we take it out, or we add it as a truck charger.
Interesting. Yeah. And I also read something about a chip, what you call it, chip?
eTrucker chip, yep.
Yeah, can you elaborate on that one?
So the way payment for trucking currently works, it's quite interesting space, and we'd love to sort of play a part in enabling this, is that often a logistics company will make a deal with a specific charge point operator in exchange for a certain volume commitment in kilowatt hours. And, logistics companies, if they have a few truck, they're actually talking about millions of kilowatt hours that they might be charging in public. And so, yeah, there is some sort of leverage there to negotiate prices. And what that usually means is that from that charge point operator, you get a charge card, you put that into the truck, and the trucker will use that then to charge there. But if you do that with 2 or 3 different CPOs, then you start to get 2 or 3 RFID cards. Then maybe add a few more for your depot chargers at your own home depot, or also at some depot sharing opportunities. And then we get into a similar situation where we were with the cars, where you have 10 different RFID cards, and each mistake of pulling the wrong card can actually be a really expensive mistake because you're charging up to 500 kilowatt hours. And doing that at the wrong price makes the whole route potentially unprofitable.
Yeah, that's quite a big cost, yeah.
Yeah, and so what the eTrucker chip allows us is to maybe combine some of these cards together. So you can tell the logistics company that where you often charge, hey, you don't need to give me another card. Here's the token for that I already have in the vehicle. Please just add that to your system and let me charge there. And the same also works for bigger CPOs, where you can tell them, hey, this is the card I'm using. Please add it to your system and then send me the bill afterwards.
Is just maybe it's a stupid question, but isn't it like the MSP then model? Or how does it work?
Currently, the eTrucker chip is not an MSP. We're not part of the transaction. We just provide essentially the physical card that can be registered in different systems. But that's an area we're looking into. Sort of what role does an MSP play in trucking? That's a really interesting question that we're sort of battling with right now, because we have these two extremes. On the one hand, logistics companies want the flexibility to pick the right charger exactly at the right spot to optimize their driving time. On the other hand, they're willing to give up a little bit of that flexibility and commit kilowatt hours to certain charge point operators in exchange for a significantly lower price. And this interesting interplay is something where we're looking into what role an MSP or in general payment solutions might play.
Makes sense. And your intention is to be then what type of players are? So it's how would you call yourself? Is it like a route optimization, a navigation app, you want to eventually be a payment service? And what will be the business model? Yeah.
So we look at this from the driver's perspective, and then an extension from the logistics company perspective. What do they need to succeed with electric trucks? And whatever they need, and wherever we find a opportunity, that's what we're going to provide. Currently, it's the map with manually verified POI data for each individual charger. That we believe has a lot of value right now, even though the app is free. Anybody can just go to the App Store, download the eTrucker app. Even just as a car driver and saying, hey, I want to be part of the eTrucker community and verifying location. So that part will always be free. But then this interplay between sort of the flexibility you need and the flexibility you're willing to give up as a logistics company to be, break even or profitable, that's where we want to help the logistics company in the future.
All right. That sounds interesting. And the stakeholders, we've mentioned a few that you have to engage with. I think in German, Spedition is freight forwarder, I think in English, right?
Yep.
So driver, of course, is essential, but do you also need to coordinate with the freight forwarding company, or is that not relevant for your app?
Yes, so we do see different solutions coming from it from both sides. So coming from the freight forwarder or the logistics company in general, really planning centrally the route for the driver and sort of recommending them where to charge. And right now we're coming a little bit from the other side and saying, okay, actually, if the driver is responsible himself, and especially you always have problems, even the best plan, and even if you have a backup plan, things go wrong. And that's where
everybody has a plan until he gets hit in the face.
Absolutely. That's what we see, and that's sort of what Tobias shows us every week in his videos. That's just an exciting space to be in. Yeah.
Okay. And the idea of I think so it's would be the customer. So the freight forwarder has to bring something from A to B. And so there are different logistics companies, or the customers of the logistics companies that could set up chargers. Is that a stakeholder that is relevant for you, or you purely now look at the public chargers, so more the charge point operators than public?
No, we do see that there is an opportunity for sort of private depot charging to be a little bit cheaper than public charging. And what we cannot forget ever is that logistics companies, they do care really about what the price of a kilowatt hour is. And if they can save a few cents, that's generally what's going to happen. So if we can find depots where they can charge cheaper, that's where we'll go. And we currently, we do include depot chargers in the app. We mark them to say, hey, you actually need to register before you go here and sort of make a contract with the depot. But, if you drive past one of these depots every day, it'd be nice to know that actually, there would be a good charging opportunity there. So we want to sort of be a platform for logistics companies and charge point operators, essentially, or these depots with depot chargers, to come together and find the optimal route, because that's really what we're here for. We would just want to make electric trucks a reality in Europe.
Makes sense. And you built, I think, the product quite quickly. I don't know how much it took you to build the app.
So Matthias is an awesome software developer, and he really created it quite quickly and super high quality. It works very well. And but also, of course, we're not trying to overcomplicate things. We focus on what's really adding value. We include that and cut out all the rest. So that enables us to be quite nimble right now.
And how many users do you have right now, and how did they find you?
So we have over 8,000 downloads right now, which exceeded my expectations by a lot. And we probably have.
Are there even so many eTruckers?
No. That's what's really awesome, is that most of them are just part of the eTrucker community. Also, driving normal trucks, but also we saw great interest from people going with their trailer on vacation. So normal cars, but with a Wohnwagen.
Right, it's a similar use case.
They need similar chargers. So we have a lot of those on the app as well.
Funny.
Yeah, just people providing feedback to the different chargers, and that's what we're so thankful for. How many feedbacks, like we get up to 20 feedbacks per day. And that's just verifying another charger, showing us new ones, and telling us which ones aren't really truck capable. So we're super thankful for that.
And usually you want to grow by word of mouth, or is Tobias actually, his videos I imagine are also super good to get new users to find you, or do you have also a strategy on how to get more users?
Yeah, so we're now more focused on getting other logistics companies on board, and we want few users, but really high value users, because with the eTrucker app we're kind of controlling flows of many thousands of kilowatt hours. So each user or truck driver is valuable to us, and we're super thankful for everybody that uses it, and they also have an opportunity to sort of give back by providing feedback and yeah.
Yeah, makes sense. I don't know if you know new entrants like Juna from Zenda.
Yep.
Would that be something interesting that would be a partner for you, or how do you look at?
We're absolutely open to any kind of partnerships, and we also provide the POI data through our partner EcoMovement. So you can approach EcoMovement to ask for the eTrucker data, and then you can use it sort of in your own front end or application, and that way we're sort of sharing that to anybody who might need it.
Okay. And just zooming out a little bit on the market of long haul trucking, can you share some numbers, like how many long haul trucks are there, how many are electrics, and maybe distinguish them also by geography?
Yeah, so that's always an interesting part of the job, is that sort of reality check. Of course, if you only watch Tobias's videos and you think, electric trucks are here, it works, everything's great, why isn't everybody doing this? But talking to the logistics companies, that gives you a reality check to say, there are some considerations and some maybe imagined drawbacks of electric trucks that need to be addressed, and where education needs to happen. And
like, for example, what kind of objections do you get to electric trucking?
Well, the most common one is that they're not suitable for long haul trucking, and only sort of local point to point.
Because of range?
Range, and that's the main one, and charging speed. And there are a lot of players that are also calling for the megawatt charging system, or the MCS plug with much higher charging power. And they say, we need to get those chargers first in the ground before we can even consider electric trucks. We don't believe that to be the case, and I think Tobias shows it every week that it's...
debunk this myth.
Yeah,
it's
for us...
It's a myth, you could call it, right?
Yes, and there might be some use cases for MCS, this megawatt charging, but we really haven't found them yet. But so
just debunking it, why do you think it's not needed to get started? If some trucker or freight forwarder is listening to this?
Yeah, so if assuming you can charge overnight, a truck starts the day and can drive 4.5 hours at 80 or 90 kilometers per hour, and that gets you around to maybe 40% SOC on one of these big trucks. The Mercedes E-Actros 600 is a great example where they just have they're not empty after these 4.5 hours. And if you plug into, let's say 250, 300, maybe even 400 kilowatts of power, you get back up to maybe 70% even, and then you're only allowed to drive 4.5 more hours, and you just can't empty a battery in a day. It's just doesn't really happen. The only thing you need to do is you need to use the eTrucker app, activate the overnight parking filter, and find that place where you can charge overnight. And then you can do that every day. And there really is no reason why it shouldn't work. So yeah, as I said, 400 kilowatts of power is plenty. And what I do kind of would like to see is in the eTrucker app we also note down, is the cable cooled or uncooled? And that doesn't really make a big difference for the logistics company, but liquid cooled cables, they're really awesome. They can hold the power for the whole hour that a truck might charge. But of course they also produce a lot of heat waste because the cable is actually much thinner. The copper wire is much thinner. And their uncooled cables are also quite good because they don't have these losses. Of course, after 10, 15 minutes, they might go into derating, and you need to lower the charging power. But even those are perfectly fine for a 45-minute charging session in most cases. Yeah.
So coming back to the initial question, how many trucks, long-haul trucks, are there in Europe? In electric ones?
Yeah, so
right now,
I don't know right now, but we see about a little bit over 100 truck drivers in the app that have sort of the usage profile of an electric truck driver, and but we see it growing every day, and I think new truck sales are actually quite electric heavy. We hope that trend continues, and that these trucks will be, given the full capability of being also long-haul trucks.
And I think 2030, I think 30% of new sales of electric trucks will be electric. I'm not sure if you're familiar with that stat. Here in Germany, there was, or in Europe was it? I'm blanking a little bit on the exact one, but something like that. And then I imagine they're broken down more on the first distribution trucks before having 30% long haul, or is it something that you are confident will also happen in the long haul?
So, currently maybe I'm living in this bubble, but I'm confident that it will become apparent and clear that electric trucks are cheaper to operate. I think right now, but
let's talk numbers. Maybe for the one that is not so familiar. In which way is it cheaper today already?
So of course the truck costs a little more, but electricity is just cheaper than diesel gasoline, even the highly subsidized diesel. So there the electric truck already has a slight edge, and now it all depends on how many kilometers you drive to really exploit that edge. And yeah, Tobias has a few videos on breaking down exact the numbers in euros, but and
we'll find it and put it in the show notes.
And we do believe that it's a tipping point. So as soon as you reach this point, and it might be different from each country, but if that tipping point is reached, there's no real reason for logistics companies to still be buying new diesels. And the electric trucks, they get turned over more, they only serve in their capacity, a few years, and then it gets turned over. So by 2030 or 32 or something, we'll have gone through almost one complete overhaul of the whole fleet. So the transition to fully electric could be much quicker than in passenger vehicles. Because
super short.
Yeah, and also emotional factors play less of an issue, and our job right now is just to clear out all the roadblocks, clear up with all the misconceptions, and let the economy do its thing.
Yeah, and the long haul, as you define it, or as it's defined, it would be not only one country, right? So you are immediate from day one already using your app internationally,
Yeah, so actually This week we launched the map also for Spain, Portugal, UK, Belgium, and Romania.
Not bad in 1 week.
Yeah, in addition to, of course, the network we already have. So we essentially cover the whole of Europe right now. Of course, we wanted to do it step by step because, as I said, we manually verify each location, and we don't want to show any locations that haven't been manually verified, so it just took some time to go through each and every one. But yeah, we're really happy that we finally covered Europe completely, and but we don't plan to go much beyond that for now.
And going back to the objections you hear when you talk to truckers or companies freight forwarded, what you said, the range is one topic that they bring in, which we already talked about and how it can be solved. Are there other big objections that you face?
Essentially the charging network. So range and charging network, of course, go a little bit hand in hand, but as I said, you need to find a location at the end of your driving time each day. So yes, you do quite need a quite tight network, and but you don't need fully dedicated truck sites. We're super happy that they're coming online, and of course if we get more and more electric trucks, we'll need just bigger sites. And I'm much more a fan of having fewer but bigger sites. That's sort of also one of the lessons learned I took away from my time at Tesla, is it's smarter to have fewer but bigger sites. And I think they were really pioneers in sort of understanding, I guess, waiting queue theory, which sort of describes, the average waiting time depending on how many servers or chargers you have. So that's what I'd like to see, these really big central hubs, and we don't need that many of them, but...
Which Milan's, for example, is building.
Yeah, like that. Of course, we also need to talk about prices. So I want charging to be at some point profitable for the CPR. I think that's fair. We need to give them at least a chance to become profitable in a reasonable amount of time. And just calling for, we want charging to be cheaper without sort of considering the cost behind that isn't really going to be a long-term solution. So I'm not a huge fan of these really price undercutting and thing. I am a big fan of sort of optimizing your costs, making sure that you build cheaply and effectively and don't make mistakes. And that's something Tesla did very, very well, and that's why today they can still offer some of the best prices out there. Unfortunately, none of the Tesla superchargers are truck compatible.
No?
No, so on the one hand, the cable is a little bit too short, and on the other hand, the supercharger cabinets only go up to 500 volts, and essentially all the trucks are 800 volt vehicles, and that's sort of preventing that. But there are enough other chargers that can go up to 1,000 volts, and I actually don't mind anymore. I think Mercedes now launched the CLA without the 800 volt option. At least that's what they announced. Then they changed their mind again because of backlash. But you can get through Europe on 1,000 volts, no problem.
Interesting. And are there countries where even if you were to be the most optimistic eTrucker, you would say that's not possible? So
that's sort of one of the biggest eye-opening things is I got through, at least virtually, and also sometimes I visited them myself, but visit each of these countries and look at how they build high-power chargers. And you're right, there are huge differences, but it's actually not the countries that you kind of maybe expect. But Tobias's trip 2 weeks ago to Turkey actually was mind-boggling how good the infrastructure was and how many chargers there was and how
Right.
powerful they were. That was surprisingly good. And also the Nordics, they have really good networks. But you also see, of course, the countries that where space is a scarce resource. Germany, Switzerland, they don't have that much space, and it's much more difficult. Spain, of course, is my favorite country right now for trucking. I think they've got a great network. They got so much space. Spain's really, really good. The UK, surprisingly, not so much. Not that many good chargers, very narrow roads, very little space for the trucks. I'm a little bit worried about the UK right now, but also Netherlands, also again, not that much space, a lot of older hardware going.
Charger hardware.
Yeah, because they started a little bit earlier, and that just means you have a little bit older
Legacy.
Hardware legacy. Yeah.
Makes sense. And talking prices, you already hinted upon that. That's the key, the total cost of ownership. What's the price difference from CPO to CPO in the range or the average that you have encountered?
So we see, you need to either include or exclude value-added taxes, but the range, of course, goes, from 39 cents to 80 cents in some cases, and 80 cents just doesn't make sense
per kilowatt hour gross.
Yes, sorry,
gross, right?
Yeah, and that just doesn't really work, and it might work for passenger vehicles that just charge maybe 60 kilowatt hours, but if you're charging 500 kilowatt hours, it makes a huge difference. So we haven't really found as an industry or ecosystem yet the perfect solution, but I think we have the right people at it, and the motivation right now is really great. We see a lot of interest from the charge point operators in making their sites more truck friendly, making maybe also business offers for trucks. So we see that as a very positive development, and we want to help them make their payback times for the charging sites quicker.
Yeah, makes sense. And in terms of kilowatt hours in the battery, what size of batteries have you seen?
So long haul trucks go from 500 to 600 kilowatt hours, some even a little bit more of usable battery energy. Of course, actually, that's one of the fun topics. Is it's actually not that easy to exactly say how much energy is in a battery. It kind of depends on how you discharge it, how quickly, at what temperature. And actually, when you stop discharging, that determines how many kilowatt hours exactly you can pull out.
So how you drive? If you drive faster,
less
fast.
But it doesn't really matter because these batteries are so huge and they have awesome range.
Yeah, and it's roughly 1 kilowatt hour per kilometer, right?
That's what we've been seeing, which makes calculating these stuff really easy. We'll see it maybe in the winter it goes back up a little bit, but that's what we're at.
In focusing a bit on depot charging, do most of the truckers that you currently are monitoring, like you can see from Toby in his videos, and the Nano Janssen, they have lots of charging infrastructure at the depots. Is it a very common place now that the electro truckers today, they can always rely on a own depot at their company where they can charge? Or
yeah, that's usually one of the places logistics companies start, is to ask the question, okay, how can I add chargers to my depot? And there, of course, very quickly they'll hit into the wall of the grid capacity. That's probably going to be an issue. And then, you see some companies that say, okay, let's do this anyway. Let's try it with maybe also lower grid capacity.
Like how much is a typical grid capacity at these logistics companies, do you know?
It really depends on sort of the history of the site. If it has historically been a great big industrial area, they might have a lot of excess capacity, but usually not so much. And you can probably, in many cases, only add maybe 100 or 200 kilowatts of power.
Yeah.
And then the question is, okay, what role does battery buffer play? I assume others are probably more an expert on that, but it's not a one-to-one replacement for grid capacity.
And it's mostly DC charging, right? Even at depot, it's not AC.
Yeah, AC, we don't see much AC charging for trucks anymore. I guess that's fine. I don't expect that trend to, jump over to passenger vehicles, but for trucks, it kind of makes sense.
And in terms of chargers, is there like a hardware? And we see the Alpitronic being everywhere. Is that the preferred? Also, depots are often with Kempower, I think, is a very known brand. Yeah.
So was also really interesting is going through sort of also historical videos, pictures of sites. I look at every individual charging site, and usually also on Google you can see sort of historic pictures from 3-4 years ago, and you see all kinds of chargers being used there. But if you then look to the most recent picture, often you do see an Alpitronic hypercharger there. And it scares me almost how many sort of other charging hardware they have replaced, and charger hardware that I thought at least was fine, even those got replaced in many cases, and I guess that's okay. I also do see a big trend towards these sort of distributed systems where you have one central power cabinet and multiple dispensers, kind of what Kempower has been doing. I think the Alpitronic version of that will also do really well. But we also see that we as a trucker, we would like to have some predictability. And, for a truck, it does make a difference if you're going to a Hook 400 or a hypercharger with 400 kilowatts. You don't really know, am I going to get the 400 or is somebody going to plug in next to me and I'm only going to get the 200? And when you only get the 200, maybe you need to charge a few minutes longer and sort of extend your break beyond the sort of legally mandated 45-minute break to really get to an SOC that you're comfortable with continuing with. So that's one of the issues. But on the other hand, I'm happy to see a lot of Alpitronics out there because they have been shown to be quite reliable. And that's, of course, the worst case is, if you, as a trucker, go to a charger, it doesn't work, but you don't have any remaining driving time left. You're kind of stuck there. You need to wait 45 minutes, and then you can start finding a charger, and then you need to charge for 45 minutes again. So that's the worst case we're trying to avoid with the app.
Yeah, I don't know if you know, but it's while we are at it in the industry, charging industry also is very aware of this, and I think some EV drivers as well. There's a bit of an issue with reliability, and that's why also Alpitronic has won so much market share, because they were known to be very reliable. What made their reliability? What were they doing better than others?
Actually, coming back to what I mentioned earlier, this software. So they're one of the few manufacturers that actually make a lot of the software stack in-house. Also, this 15.11.8, ISO 15.11.8 software stack, they do have expertise in that. They also have a huge team, of course. That's what you need to be able to do this in-house. But it apparently translates a little bit into higher reliability. Even though I have to say I'm not a huge fan of the user interface, I still don't understand why, as a user, I need to select the plug I'm currently using that I already plugged in. That's something the charger could recognize automatically. I don't know why they don't change that.
Okay. And in terms of charge point operators, is there like in all your analysis so far, some that you like to prefer or that you find are better than others? For trucks in particular?
Yeah, I mean, we're really excited about all the Ionity chargers because we know, okay, they all have 300 or 350 kilowatts. They all have liquid-cooled cables. It's a little bit interesting because now Ionity also has these mixed sites with like ABB liquid-cooled charger with 350 kilowatts, and Hypercharger 400, usually without liquid-cooled cables. And for the truck driver, they need to make a decision, which one do I use? And I'd mostly recommend them actually sticking to the 350 liquid-cooled charger and not go to the slightly more powerful 400 kilowatt charger.
Because the power drops eventually.
The power will drop, and there's a big risk that somebody plugs in next to you and you only get 200 kilowatts.
Yeah, the load management, that's something that many people maybe don't know or are not as familiar with, and that are wondering why they don't get then the full power that they were expecting, is because, maybe to explain to the listeners, there is always a load management on site, right? And maybe you can elaborate what type of strategies you have discovered so far.
Yeah. So this is something we take very, very seriously. This is something we've been adding to the database from day one, is sort of what is the load management at site. So this peak charging power, how much can I rely on it? And we sort of have three levels of sort of high load management. That means that there is a high probability that you'll get significantly less power. Or we have low load management. That means you're almost guaranteed to get that power. And high-powered charging sites are usually load managed if it's a centrally managed one power cabinet with multiple dispensers. The power of the power cabinet defines what the maximum charging speed is, and the more people plug into the same power cabinet, the lower the power. And the grid connection usually matches the power of the central power cabinet. If you have multiple of these central power cabinets and multiple systems, there probably is sort of a load management going on between them as well, where they cannot actually operate every power cabinet at full capacity at the same time. Similar to when you have these all-in-one systems from Alpitronic, for example, there if you have 10 chargers with 400 kilowatts each, they cannot all operate at that power at the same time, which is kind of a little bit wasteful because you have sort of AC to DC power converters there on site that can't be fully utilized. That's why these satellite systems, where it's one central power cabinet, have some advantages, because you only have exactly as many AC-DC converters as you have grid connection.
Yeah, and there's also peak shaving, going on sometimes by the charge point operator, not only to protect the circuit breaker limit at the grid connection point, but also to save some money on the peak they have to pay for this DSO, right?
That's if they're smart, they have a peak shaving limiter in there as well. But the question, of course, for the CPO is, okay, where do I actually set the limit? Because if I expect actually the site to be at full occupancy regularly, I should probably be willing to pay for the full grid fees. If I think it was a fluke, and I actually don't think the rest of the year there'll be ever a situation where everything is in use at the same time, then it doesn't make sense to give the user the power, even though the grid connection is there, even though everything's ready. But if you do peak shaving, you're not giving the user as much power as you could, because you're trying to save money.
And one thing also that is interesting, I think, is the difference between trucks and passenger vehicles. So the EV driver that knows the charging peak it can get from a 350 kilowatt Ionity or whatever other charge point operator, they never reach at this point in time still. Most of the vehicles are capped because of the onboard electronics, right? So you have a 400 volt system, and it mostly can get, I think, Porsche was 400 or 800?
No, the Taycan was the first 800 volt vehicle. But actually the voltage of the battery doesn't play any role in sort of how fast the car can charge. The only thing that matters is battery temperature and SOC. And the voltage only means essentially if the charging cable going from the charger to the vehicle, if that's a limiting factor or not. Because these cables can typically, if they're uncooled, only be boosted up to 500 amps for a short amount of time. That's just the advantage of an 800 volt system, is that you can, with the right charger, then do 500 amps continuously. And that's sort of what we see happening. And that gets you to almost 400 kilowatts, and that's what most trucks are actually pulling.
But isn't the power the multiplication of the current and the voltage?
Yep.
So if you have an 800 volt, you would have double as much as a 400 volt.
So if you have 800 volts, you can get the same charging power with half the charging current. Mm-hmm. And the limiting factor...
But with the same current, you would have double.
Yeah, sure. Yeah. And the limiting factor is usually the charging cable from the charger to the vehicle. And there, if you have an uncooled cable, it helps a lot to have an 800 volt system.
So trucks have a bigger cable than passenger vehicles. That's the reason they can charge at those high level of power.
So trucks can go up to 400 kilowatts. They can actually go much higher. So 400 kilowatts doesn't really tickle a truck battery, because if it's 600 kilowatts of total energy capacity, the C rate was what you call the sort of relation between charging power and battery capacity isn't very high. So they could probably charge also with 800 kilowatts. That would be then starting to be interesting, which is great, because that means you don't really need to precondition the batteries before the truck charges. Passenger vehicle cars, they need to be very carefully usually brought up to temperature. So you need to preheat the battery, which actually wastes quite a lot of energy. And then you plug in, and then it can charge really fast. But if it charges really fast, it means that also there are a lot of losses, and then you need to cool down the battery again. So everything you warm up the battery, you later have to cool down again. So that's great. With trucks, you don't need to really precondition, and you always charge quite quick.
Because what happens if you charge a battery at a low temperature?
The battery management system will simply not allow a high current, and you'll be stuck with the low charging power.
Because the battery gets damaged.
The battery would get damaged if the battery management system wouldn't limit the power, yes.
Yeah, so that's the whole game with preconditioning, that you avoid damaging on the one hand, and even just empower the battery to charge at higher currents and therefore higher power, which is a big topic. I think in one of the videos, the last videos I was watching, Toby also really was looking at how each OEM has made the logic of the preconditioning work, right? That's something that the OEM decides on how it also works, right? Yeah. You don't, as a user, you don't have so much flexibility, or do the truckers. And I think it affects the trucker in his day-to-day as well, how this preconditioning works, right, in the planning. Yeah,
as I said, the trucks don't need that much, because the charging power isn't that big compared to the total battery capacity. But what I did find very interesting is that most trucks have sort of a way to limit the charging power. Even the default is usually to charge at a lower power, and you need to individually click a button to unlock the full power. I'm not quite sure if it's due to battery longevity or because of load management. They may think it's easier, but that's something. If your truck isn't charging as quickly as you were hoping, check if that's not an issue.
Yeah. And talking about the tours of each trucker, how can I imagine, is it like very fixed for each week? Or also, I mean, in the week, sometimes you see these changes of Toby in the videos. So how frequent is this plan disrupted in terms of, there's a new order coming in?
Yeah. So what Toby does is relatively representative of what the typical long haul trucker does, meaning that yes, you're constantly looking for stuff to transport from A to B, and you are always trying to find a return thing to bring when you go somewhere. You're trying to get something on the way back. That's
there's
very
a spot market too, no?
yeah. There's different markets where you can sort of get that, but those usually don't pay as well. So you probably earn more money on the way there and try to just cover your costs on the way back. That's typical for a long haul trucker. But as I said, there are also a lot of trucks just doing the same route every day, or having sort of a weekly schedule that looks the same every day. You know, it's a tough job. Not sleeping at home many times, and being in all kinds of situations. It's a hard life, and I greatly respect the service they do. Everything we own was in a trunk at some point, and we need to, you know, help them decarbonize and go electric, but it's not a given, and we need to be thankful.
And talking a bit about the trucker life or behind the curtain, so everybody who's watched the videos and who hasn't recommended to watch the electric trucker videos, what's the behind the curtains that you get to know of Toby?
You know, he's great. He's super honest. He says it like it is, and so it's not that much different behind the curtains. But it is a hard life, and he makes it look easy. And I think that's something we need to keep in mind, is that, okay, we need to support our truckers with the right tools to make it happen, because not everybody is sort of coming from the charging industry and has all this knowledge. Also, we just talked about sort of charging power and how to use all the payment devices and do all the settings. That's, you know, hard stuff, and that's also a role for us where we can educate truck drivers on how to drive an electric truck.
Yeah. But will eventually truckers also use a credit card just to pay, or to make it easy, or?
So for trucks, typically not. Truck drivers so far don't really get issued a company credit card. You know, it's something that wouldn't be a huge issue, and in other markets, in America, for example, it's normal to sort of issue a credit card. You can even have something called a merchant category code restricted credit card, which means you can only use this credit card for specific services. So, for example, just for charging, or just for charging and washing your car. For passenger vehicles, I had some hope for this kind of card to become more common, but right now, I think we all agree the system's kind of broken. The price you pay per kilowatt hour with the credit card is more of a price signal to the other players in the ecosystem. Hey, this is sort of my initial offer. Come to me, let's negotiate a better price and find that. And sort of, if you pay with credit card, you're kind of the loser and not really getting the price you deserve. Yeah. I think that's a tragedy, and it's really sad. I would love to see, you know, more dynamic pricing as well. I love on-peak and off-peak pricing. I think you know, our infrastructure is very valuable. Soon we'll have more cars and trucks on the road than infrastructure, and we need to balance things out. And the best way we can do that, and the best we can fairly do it, is by making it more expensive when we have high demand, and less expensive during off-peak hours, and spreading out the load. And it's not great that we don't really have the systems, because I think CPOs are willing to go this way, but the way we currently have it set up with MSPs in the middle, they can't really forward those dynamic prices so well to the end customer. So we're in a system, we're kind of like in this Nash equilibrium or prisoner's dilemma, where everybody's behaving according to their own best interest, but we're not at the system optimum. And we need some sort of jolt or change in the rules, even though I'm not a big fan of regulation. I think we sort of over-regulated the charging ecosystem by quite a lot right now. But we need some shock to the system to get us into a better equilibrium.
So going in that direction, having a spot market, for example, orientation also in the dynamic prices for a trucker would enable to even charge even lower price, right? At the noon when there's lots of sun.
Yeah, I mean, the question is sort of what you want to optimize for. Do you want to optimize for the congestion at the charging site, sort of when you have a lot of demand and you want to avoid waiting lines? Or do you want to optimize for the energy purchase and sort of enabled to offer the lowest prices by going really low when the price is negative, for example. Historically, I've been more sort of a fan of this on-peak and off-peak pricing to manage congestion, but I'm warming up more and more, also because it's just more predictable and you know exactly, okay, next week what the price will be at a certain time. But it's still time variable and still spreads out the demand. But more and more, I'm warming up to the idea of having the day-ahead prices or the spot market prices go straight to the vehicle. That, if you make it transparent, seems like a fine idea.
And when the truckers have this long hours then during the night, do you even see bidirectional charging be an option where it's there was 9 hours or 10 hours
yeah.
while the vehicle's there?
So yeah, what we have is flexibility. The question is, how do we use that flexibility? Do we use that flexibility that they're there for 9 hours to lower the charging power to maybe 100 kilowatts and just charge for 5, 6, 7 hours? Or do we say, okay, let's install actually a fast charger, put a 300 kilowatt charger there, and delay charging until sort of the electricity is really cheap in the night, and then you charge that up. And then you can go one step further and say, okay, actually, let's put maybe a little bit even higher power charger, and then during that 1 hour where it's really cheap, we load up on energy, and then we discharge it later in the night when it may be more expensive, but then we need to recharge it really quickly before we go. So then you have more demands on the infrastructure. Unfortunately, and what I see is that the night time when most of these cars or trucks are stationary, in the energy market isn't the most interesting time of the day. So I'm a little bit concerned that the sort of charging losses that you have to a certain extent don't fully compensate that. If the truck is stationary over the day, and that might be a trend we see. Maybe at some point a logistics company say, hey, let's flip this around, let's drive at night, because also on the Brenner, for example, now electric trucks are allowed to drive at night. And that might flip everything, and we say, okay, actually, during the day we can charge really cheaply on solar energy, but then for the truck driver, of course, it's not so nice because then they need to drive at night. But if it makes economic sense, that might where it goes.
Also thinking of like longer time periods only at night, but then during the weekend, or think about stuff like autonomous vehicles that might also affect actually your business model eventually. So talking about that and getting also towards the end of the podcast, what in the future, what are trends that you are particularly excited about in the electric trucker world and in macro trends and how it would affect your business?
So right now I'm mostly worried about AI and how that's going to affect all our jobs. For trucking in particular, autonomous driving, has gone through a few hype cycles now. It should be possible at some point. But the question then is, how does recharging actually work? And that was kind of fun at NIO. We already had a system that was fully automated. So you could, a battery swap is you can do it without anybody inside, and the car can sort of replenish itself. When we have autonomous cars or trucks, we also need to think of autonomous and automatic charging solutions. And I saw a lot of also failed projects with sort of charging robots that sort of plug in from the side, and inductive charging isn't going to be relevant for trucks at all.
Why not?
You just have, in general, inductive charging, of course, you have even more charging losses. You kind of need to have something similar to a onboard charger inside of the vehicle, because those AC waves need to be converted into DC power for the battery. So you're as much power as you want to have inductively, you need to have a pretty big AC to DC converter in the car. So I don't believe that will be happening, but you could also have an underbody device that sort of touches the vehicle and gives power through that. But that's, of course, also on the underside of a vehicle is very delicate, and I don't know how robust such a system must be. So for trucks, I haven't really found a better automatic replenishing system than actually battery swapping. And I think battery swapping for trucks could be...
It's booming in China.
A game changer. It perfectly works in China.
CATL is betting on it now.
CATL has a system. We were at a company called eHaul, which in Germany, near Berlin, has a demonstrator for a great battery swap system for trucks. You just go in from the side. It's even much more simpler than for passenger vehicles. Like a NIO power swap station is a marvel of technology and super complex. For trucks, you can make it much simpler also because you don't need to worry about sort of ride comfort. The NIO power swap station is made super smooth that you don't feel scared or anything while you're inside the vehicle. But for trucks, you don't need all of that, and you can make it super simple, super fast. So if autonomous trucks comes, I bet truck battery swapping will also be around the corner.
All right. Yeah, and is there any last few messages or also ways people can contact you?
Yeah, so please, go ahead, download the eTrucker app, check it out for yourself. We'd love some feedback on certain sites you might have visited before. If you work for a charge point operator and want to sort of learn more about how to make your sites more truck friendly, we'd love to help out and help you also with site designs, because we've seen all kinds of layouts, and some are better than others, and the charge port position is a big topic there as well. But have fun, and let's get heavy-duty trucking electric.
Thanks a lot, and best of luck.
Thank you.
And this was the episode with Michael Clarke from the electric-trucker. Impressive background, multicultural, and especially working at so many interesting companies and so varied roles, starting from Tesla, where he had to convince hotel owners to install chargers, but also at Porsche in interesting aspects related to route planning and how to integrate into vehicles and different high voltage levels, and the Taycan, which was the most impressive EV of the first EV history. And then, of course, NIO on charging in the ecosystem there for swapping and what we learned on swapping experiences, prices, and especially the dynamic tariff for the EV drivers at home, being one of the first smart charging apps in the market. I also liked how he compared the different pace of innovation, and especially the Chinese one, and what we can learn from their just pace of innovation. And maybe sometimes you just launch a feature for free, and at least the feature is there. And finally, of course, in the most important bit of the interview with the electric trucker, even though it's in the infancy still, the market. It will be probably as fast as he anticipated, in my view too, considering that the long-haul trucks and generally the logistics companies really care about total cost of ownership, and the prices of these trucks have fallen dramatically, and the operational costs are very, very low compared to diesel. And there are more and more restrictions as well. And indeed, the feasibility, which is the main counter objection to using them, is as it's been displayed by Toby, which again, the videos are super entertaining for the geeks among us that like these topics. I would recommend to watch. It is possible today, and not only in some select countries, but even all over Europe, to drive these electric trucks. I found the details and the technicalities of charging power levels that we have been exploring with him, but also how charge point operator and chargers differ from one another, and the differences in prices in particular, and where the whole industry is going to go to. And of course, all the features that the electric-trucker app has and will have, particularly interesting. And I hope you enjoyed it as much as I did. And if you did, share it with those in your network that you think will like it. And let's participate in this transition towards e-trucks by sharing it and commenting on it. And see you soon.